Good evening, everybody. That time of the month again, office hours time, one of my favorite times of the month. Second favorite time of this month, and I'll explain why it's only my second favorite time very shortly. But before we get going, just got to get my several cameras and microphones all synced up. One moment. There we go. Hopefully everyone's ears are okay. Sing out on the chat line if you can't see me or hear me. Hopefully I've got this worked out now after, I think this is office hours number 50 for me. So yeah, we've been going for a fair while now. So without further ado, let's get stuck into the slides and we'll see what we can talk about in the next 60 minutes. There we go. So hopefully you can still see me slightly and hopefully you can mainly see the slides. I've made a slight change. In previous months, I always had the microphone on this side, and someone pointed out to me that every time I go look over at the slides, my voice would disappear. So hopefully I put the microphone on this side. Oh, the chat is still disabled. Sorry, hold on a second. That's my fault. I need to remember to actually enable it. Hold on. Attendees can chat with everybody. Okay, can someone smash something in the chat? Make sure that works. Your beauty, fantastic. Okay, chat is back. Chat is back online. So thanks, Judith, for letting me know. I would have totally forgotten that. So yeah, so chat amongst yourselves, chat to me. Let's make it as interactive as possible. Okie dokie, so back to the slides. As I always say, getting in touch with me is easy. If you're a modern person, you can just scan the QR code. Otherwise, you can just reach me on Twitter. That's my Twitter link on there. Otherwise, just go to linktree/Connor, which will give you blog, podcast, YouTube, Instagram, Facebook, TikTok, email, LinkedIn, you name it, it's there. So I love talking tech. Any way you'd like to reach out to me on your social media platform of choice, I'm always happy to oblige. Next slide. If you're new to this office hours session, then don't be alarmed when you see all the slide content either thrust down at the left or down at the bottom of the screen. That's because when we turn this into a video at the end of the session, we put my ugly mug at the front of it and the top right, and therefore there's nothing worse than having slides where the video, the webcam overlays some of that one critical piece of content that you were actually after. So we try to do that such that when we turn this into a video, for those people that couldn't make it live, they'll be able to actually still get plenty of value out of the content. Ooh, chat's gone live already. Okay. Oh, someone said, thanks for yesterday's presentation. Yes, I'll come to that very, very shortly. Okay, let's put this under here so I can see when the chat comes up. Couple things. It would be remiss of me not to mention that in just over a month's time, or was it under a month, just right on a month's time, is Cloud World, the premier Oracle Corporation event for the year. Very, very excited to go there. I've just been told that, yes, I'll be doing a couple of talks there. And so I booked my flights today. So very keen to get to Las Vegas. Never been to Las Vegas. And if you've never been, you can come along and be a newbie with me. We're looking forward to seeing the strip, but most importantly, looking forward just to seeing so many people face to face again. It's so nice to be, I hate to be saying this over Zoom, but it's so nice not to be doing Zoom stuff and actually having the chance to meet with people face to face. So if you've only got one thing you can go to, only one thing your manager will budget for you this year, try get along to Cloud World. So in terms of Cloud World, I think last month I was all excited because I said, we've got over 700 sessions there. Well, we hadn't actually finished the catalog by then. So now you can see there's over 1,000 sessions of content at Cloud World. So just about something for everyone, I expect. Chat line keeps lighting up. And someone said, yes, will it be a 16 hours flight? Yeah, a little bit more. To get to Cloud World for me, it's Perth, Sydney, an overnight there because I can't make it in time for the next flight. Then it's Sydney to Dallas, that's 16 hours. And then it's Dallas to Vegas, and that's 3 hours. So yeah. And then I'll be bright and perky as you'd expect when I get to Las Vegas. Oh, missed one. If you're not in Australia and if you're not heading to Cloud World, then if you're in Europe, there's still plenty of goodness for you. Starting soon, or it may have already started, is the EMEA tour. Some of it's virtual, some of it's in person, but yeah, get along to any of those. You can see there's literally lots of consonants in those names, but yeah, lots of great places. I wish I could go there, but the reality is I don't think my body could take doing that kind of tour and then jumping on a plane to Cloud World as well. Otherwise, I probably would have been there. Fantastic sort of event and lovely hosts that run those events. But one thing I am going to for September is in, let's see, tomorrow or the next day, I'll be jumping on a plane and going to Nuremberg and for the DOAG conference. For those that probably have been around user groups for a long time, you will know that DOAG is probably one of the larger events that's held by user groups each year. There's, it's always been like UKUG, ODTUG, Kscope, DOAG, one of the premier events. But for me, first ever DOAG. Since I lived in the UK in the late 90s, it's always been like, oh, I want to go to DOAG, but never ever got a chance. So yeah, first DOAG for me. I'm very much looking forward to that. Got a few talks on there, including a non-technical talk, which is one of the first times I've done a non-tech talk. So check the DOAG agenda there if you want to get along. I'm sure you can still get along to that if you're in the vicinity. The reason I said this month's office hours is my second happiest time is this was my happiest time, and this was yesterday. For the first time in about, let's say, since 2019, we're talking pre-COVID, I actually got to go to the Perth, where I live, Oracle office, get some local Oracle Perth customers and do some local Oracle Perth content and catch up with the local Oracle staff there as well in the Oracle office. So just ticked a lot of boxes for me. We had a session on 21C features, plus a look at what's coming up perhaps in Cloud World. Huge amount of fun. Thanks to the Oracle office in Perth for putting that on and helping me out there. Some of you may have seen it. We actually live streamed it over LinkedIn as well. So we tried to make it available to everyone who was in a relevantly convenient time zone. Anyway, so that was my happy event for the month. That was fantastic. And hopefully, I suppose what I'm saying is, I've lost my mouse focus. All of these things I say every month are all about support your user groups. This is about, that's about as local as I can possibly get. Please support your local user groups. Let's give them that kickstart that they deserve, because they did it so tough for the last couple of years over COVID. Let's get them back. Let's get our communities back bigger and stronger than ever. I want to mention one thing now, which if anyone who's not my age on the call, probably this will mean nothing, but Dave Ensor passed away, I think earlier this week. Some people who are old-time Oracle people reached out to me to let me know. For those people that don't know, if you probably know the name Tom Kite. If you think about the generation of Oracle luminaries, perhaps before Tom, that would number one on that list would probably be Dave Ensor. If you've ever used things like StatsPack or AWR, Ash, etc., he was one of the pioneers of actually having a performance group inside the Oracle Corporation. And we're talking here in the late 80s, early 90s. So from that sprung people such as Graham Wood, the inventor of Ash and AWR, John Bereznevich, etc. A lot of the people who became famous as performance experts in the Oracle community, Carrie Millsap, etc., owe a lot of their background to Dave Ensor, who worked for Oracle and then ended up becoming an independent consultant. And he passed away earlier this week due to illness. So I have a personal story. I hope you'll bear with me for just 2 minutes to give you my personal story. Is I was working in Perth on an Oracle 6, Oracle 7 site, my first exposure to Oracle in the very early 90s. And because I worked for, at the time, one of Australia's biggest companies, I thought, well, I've got my Oracle databases up and running. I thought I was the bee's knees. I thought I really knew what I was doing. And then Dave Ensor got invited out to Perth because he was often sought after anywhere around the world in terms of Oracle performance expertise. The local Oracle office got him out to Perth, and he did a talk on 20 mistakes you're probably making with your Oracle database. And here I was thinking, well, this won't apply to me because I've been working with Oracle for a number of years now, and our databases seem to be going okay. I think I ticked off 18 or 19 of them. So I was making like 95% of the silliest errors you could make. And it took him to point them out to me. So it was fairly humiliating, but that humiliation was what kickstarted me to reach out to places outside of Perth to try and improve my Oracle knowledge and understanding. That led me to Usenet. Usenet led me to meet people such as Tom Kite, Jonathan Laws, etc., because that's how we used to lurk in terms of community on the Deja News forums. Because of that, I thought, well, the Y2K thing was coming around. A lot of the people I'd met with on the Usenet groups lived in Europe, so I moved to the UK for the Y2K, and also it was a good time to get work. That led me to the UK Oracle user group, hence that's why you should support your local Oracle user group. That led me to start doing some presentations in the Oracle workplace and Oracle sort of user group community. that led to a competition that BMC, who Dave was working for at the time, ran called the Smart Dba Challenge. You had to write an essay and some code. And I was lucky enough to win that, which got me a trip to Open World in 2002, I think. And finally, the prize, as well as going to Open World, was a dinner with none other than Tom Kite and Dave Ensor. And that very young man looking at the right there is me, some 25 years ago. So that was the first time I met Tom Kite and Dave Ensor face to face, being the lucky winner of this prize. And so, yeah, so Dave, myself, and Tom go back a long, long way. He'll be sadly missed. And thank you for indulging me that couple of minutes. But yeah, he was a legend. Sorry, someone put in the chat there. That's right, what nice times. Yes, the net was not as noisy as it is nowadays. Thank you for bearing with me. Let's look at how are we going for time? Oh, we're behind already. Let's look at what we'll try cover tonight. We'll run through them as quick as we can. We've got standby database and undo DDL tracking, the alert log when it comes to the cloud, because if you're a DBA, I know you love getting your fingers into the alert log and what happens when you're on the cloud. Database defaults. If any of you are running standard edition or standard edition 2, what kind of hardware is the best for that? A little investigation into VDOLA flashback database log file and data pump and virtual columns. 7 things to get through. It might be a challenge, but we'll do our best. Drink. Man, the chat's going off tonight. So standby database and undo retention. Here's the question that came in. We use Active Data Guard in order to offload reporting from our primary server. Excellent choice, very common use for it. We increase the undo retention parameter on the standby node, but we're still getting the occasional ORA 155, snapshot too old error. Can you explain what is going on? So there are 2 very important considerations here when it comes to understanding undo on a Active Data Guard or standby database. So the first one I want to talk about now is undo retention on the primary. Now, you're probably familiar with the fact that when you set undo retention on the primary, you choose effectively how long the database will endeavor to hold on to undo such that queries of at least that length should be able to complete without getting a snapshot too old. The default is 900 seconds or 15 minutes, but let's assume I've set that on this same database. The first thing we need to understand in terms of considerations is that really doesn't apply anymore. Now that sounds a bit strange. That's why I put this tilde or an approximation next there. We worked out in Nightside Oracle that if some undo got older than 15 minutes old, then why would we go to the effort of throwing it away? Because that takes resources to clean that stuff up. And if our undo table space is not running out of space, then why bother? So what we actually do is we simply hang on to undo until such point as we forcibly have to remove it, i.e. we need some space in our undo table space. So the way to see what your real undo retention is, if you look at VDOLA undo stat, which measures this over time, you get effectively sort of intervals of time. I think it's 10 minutes, or it might be your snapshot interval. Then you see this column called the tuned undo retention. And what that is the genuine retention you are getting, which is typically going to be a lot more than your parameter of undo retention. Obviously, if your undo table space is tiny, then your tuned undo retention might not even be as high as the undo retention that's been set in the init.ora file. But effectively, this is a way of knowing what your genuine undo retention is. So what's actually going on here is at 9 o'clock, some undo might be created, and that goes into the undo segment. And then there'll be more as time goes on. There'll be undo information for changes that were done at 9:05, 9:09, 9:15, etc. And so we've hit the limit of our undo retention now. That's that little dotted line there you see in the diagram. Effectively, we say, okay, that's 15 minutes worth of undo. The next undo information I need, in theory, I could throw away that 9 o'clock stuff because the time is now advanced past 9:15. But as I said, we don't do that. We simply say, well, there's space left in our undo table space. Why would we bother going to the effort of throwing away stuff that's still there? So 9:17 comes along, and guess what? We've now got 17 minutes of undo retention effectively, even though our parameter is set to 15, because we got space left in our undo table space. And then 22 and 28, etc. Now, as the clock moves forward and people keep making changes, we're going to hit 9:30 or 9:32, and now our undo table space is near full. Therefore, at that point, we finally go back and throw away that stuff from 9 o'clock and the next piece of undo goes in there at 9:32. So on our primary, this is an example of if I set my undo retention to 15 minutes, in this particular scenario, I'm going to get about 30 minutes of undo retention because it makes no sense to artificially limit the people running their reports. All of this is undo information, and anything which changes blocks, including undo blocks in the database, needs to be logged to redo. So if we head back to 9 o'clock, that 9 o'clock change that went to both the database and the undo segment, so we could roll back that change, all gets written to the redo, as does the 905, the 909, 15, 17, 22, etc. Didn't put enough arrows in there. As a result, this is how your standby database stays up to date. The only thing the standby database gets from you in normal operation is redo. So all these changes to your database and the undo associated with them all goes to redo, and all that redo gets sent to the standby. So if we now include a standby database in here, and we repeat that same exercise, we have a change at 9:05, that gets written to redo, and it immediately gets sent to the redo on the standby side and gets applied to our standby. And so the two are in sync. Same thing, the way that works is we have a thing called standby redo logs. So as information gets logged to the primary redo logs, that gets transferred in near real time over to the standby redo logs, and from there, those changes then get applied to the genuine segments on your standby database, whether they're the data blocks or the undo blocks, etc. And that way, the standby rolls forward in the same way that your primary is rolling forward. And therefore, the next change goes into primary, that goes to your standby, next change, standby, and so on and so on. Do I keep on doing? Yeah. So that's effectively how your standby stays up to date, in the sense that your standby redo logs effectively receive information from your primary redo logs, and those standby redo log changes then apply changes to your standby database. So what that means is, as we saw here, I'm once again assuming that effectively we have a change here that we started at 9 o'clock and we rolled all the way through to 9:32, and we therefore had to throw away some 9 o'clock stuff. When we do that, the same thing happens at our standby site. As a result, the undo retention on your, or the undo duration on your standby is pretty much exactly the same as the undo on your primary. Moreover, if you started throwing away segments faster on your primary, then the standby immediately reflects that. So it doesn't matter what you do with your undo retention parameter on the standby, because it actually plays no bearing here. It all depends on how much undo and how long it's being held onto on the primary. So your first consideration is you shouldn't need to worry about setting the undo retention on your standby, because it won't do anything for you. All that really matters is setting the undo at the primary, how big your undo table space is, and your undo retention parameter. And if you want to do guarantee, no guarantee, etc. at the table space level. But all these things need to be done at the primary because they will be reflected in the standby. So that's the first consideration, is that real-time apply is the default. When you create a standby database in any modern version of the Oracle, when you go through the list of commands, or if you're on 19C or it might be 21C, you can actually just run a one-line command now, which is prepare a node for standby, and off it goes. Then what happens is the standby redo logs will be created as part of that process. So that's the default. But standby redo logs are a relatively new invention. Now, new I'm putting in quotes here. When I say new, we're talking 11G. So we're talking over a decade ago. But it is a reality, and it was the case for this customer, that some people have had DataGuard since version 7. And as a result, they've simply incrementally upgraded their databases from 7, 8, 9, 10, all the way through to 19 now, hopefully. And at no point did they actually have to, or forcibly do, add these standby redo logs. What used to happen with DataGuard is when you filled up a redo log on the primary, then we would ship it over to the standby and apply it then. And as you know, Oracle's very keen on keeping backward compatibility. So just because you upgraded to 11, we're not going to simply say, I'm sorry, your DataGuard node is broken because you didn't add standby redo logs. We put a message in the alert log saying it's a good idea to have them, but we don't force you to have them. And that's what actually happened to this customer. Because they'd upgraded from a very early version of DataGuard and they'd never had standby redo logs, and we enforce our backward compatibility to support them, they, even on 19C, they didn't have standby redo logs. So what means is this happens. You have all this information going into redo logs, all this undo information going into redo logs on your primary, but none of it's making over to the standby. The standby is sitting there effectively frozen in time, waiting for an entire redo log to fill. So here's a whole stack of undo changes going along, but nothing gets applied to the standby until that redo log fills up. And when it does, and even so, even though our undo has wrapped around, we've had to throw away some old undo and now replace it with the stuff from 932. Even though we've done that, the standby is blissfully unaware of that. But eventually the reader log will fill up and it all suddenly gets sent in one blob to the standby and gets applied en masse, just using database recovery. That has very strong implications, not just for the up-to-dateness of your standby. And originally, standby read logs are all about keeping your standby more accurately up-to-date. Because if it's only up-to-date when you do a reader log switch, then obviously there's a chance of losing data if you had a catastrophe. It's really what the standby read logs are really about that. But they have an unforeseen side effect when it comes to active data guard. Because if we look at the primary, at 9:05 in the morning, then the SCN number, the system change number in the database, reflects 9:05 in the morning. That obviously makes sense. So the system change number rolls forward with time. You make a change at 9:28, the SCN might be 928. It'll be some other number, but we're keeping the maths simple here. And at 9:32, when we actually filled up our undo table space, well, we have an SCN of 932 that needs to be saved somewhere, and therefore we threw away, as we saw before, the oldest SCN piece of undo, which was in 9:05. What that means is that for a 27-minute period, the undo information for SCN 9:05 was floating around in our undo table space. So for that entire 27 minutes, I could run a query that may have started at 9:05 in the morning. It could still be running for 27 minutes and it's going to work fine because I've got that SCN data floating around in my undo table space. Once I got to 9:32, if I had a query that was still running from 9:05, then I'd probably be in trouble because I might not be able to find information from 9:05. But because I don't have standby reader logs, all of that gets sent in one blob over to the standby. So the standby effectively will reflect the same thing. It will be 9:05, the SCN is at 9:05. But at 9:28 on my standby database, it still is 9:05 because I haven't applied that reader log yet. So at 28 minutes past 9, it still looks like the database was at 9:05. And then at 9:32, when the reader log switched, or just after we erased 9:05, when the reader log switched, the primary says, yep, ship that whole redo over to the standby and apply it. What that means is all queries that were running with an SCN of 9:05 on your standby, they're fine. But if you started a query at, say, did I put it in? Yeah. If I started a query at 9:31:55 on my standby, so it's only been running for 5 seconds. At the moment that query started, the SCN on my standby database is 905 still because nothing has come over since then. So every query says, okay, I'm reading the database as it was at SCN 9:05 in the morning, even though I'm starting at 9:31:55. 5 seconds later, all that redo is going to come flying across and it's going to be applied in maybe just 3 or 4 seconds. And literally in that 3 or 4 seconds, your SCN on your standby goes from 905 to 932 because we simply erased 905. So that query that actually started only 5 seconds ago is going to get an ORA 1555, even though it's only been running for 5 seconds, because from the time it started, the standby database says I'm at SCN 905, and then literally within 5 seconds, the standby database no longer has an idea what SCN 905 is. It's been thrown away by the application of that redo. Boom. So our considerations are, number one is all your undo retention. Everything that in terms of how long you think you can run a query for is driven by the primary. So if the longest query in your primary runs for 10 minutes, but you have queries on your active data guard on your standby that run for 30 minutes, you need to set your undo retention to a 30-minute period on the primary, because that's the only way that information gets reflected on the standby. And the second thing is, if you don't have standby ready logs, then no matter how much undo you have, you run that risk of very short duration queries being smashed with ORA 1555s because the SCN they were looking at can simply vanish under their feet. So standby ready logs are critical for real-time apply, but they're also critical for making sure that the queries you want to run on Active Data Guard are actually going to have a decent chance of success. So under retention on the primary, standby ready logs for all sorts of benefits on your standby database. Okay, hopefully that answers that. No questions, excellent. I've said this before, I won't do it now in the interest of time. Every production system you have should have a standby database because ultimately it's free. If you want to debate me on that, contact me offline on Twitter and I'll explain why, but the reality is there is no reason not to have a standby database for every single database in your organization. Number 2, tracking DDL. Officially, this is the question that came in. Last DDL time is censored word, it's broken. So I'll rephrase that into something that maybe is a bit more delicate for our viewers. We use the last DDL time to detect changes on objects in our data warehouse, but it does not always seem to change when we think it should. What's going on? And initially I thought, well, this doesn't, this sounds ridiculous. That's, last DDL time is something I've used a lot in the past. But there are some idiosyncrasies to be aware of, which I only discovered when I actually had some back and forth with this customer after calming them down a little bit. And on that note, I thought I'd show these things to you, and so you're aware of them yourself, and we'll do some exploring with our first demo of the night. Okay, sing out on the chat line if you can't see that, and hopefully the font is large enough. So let's walk through the last DDL time column on user objects. I'll start with a simple table. Create a table called T, create an index on T, throw some rows in there so we actually have some real segments on our database. So we have a table called T, an index called IX. I'm going to set my endless date format to being longer such that we can see down to the second when things change. Just makes it easier to track the last DDL time. And here we are. It's 9:27 p.m. in Perth here, and we can see that we created my table T at 3 seconds past the minute, and my index followed suit 10 seconds later at 21:27:13. Let's set the index to unusable. So this person had a data warehouse, they were making their indexes unusable so they could load data in. If I look at the DDL, first idiosyncrasy, making an index unusable on a table tweaks the last DDL time on both the index and the table. So the table gets marked as changed as well. That's the first thing we should be aware of. If I rebuild the index, then once again, both the table and the index get flagged as, yep, you've actually made an alteration to both of these objects. So first idiosyncrasy to be aware of is just playing with the index may update the table DDL as well. Let's now drop that table and make things a little bit more complicated. I'll now create a table which has partitions, and I'll create a local index on that partition table. So now when we go look at our what's in user objects, I'll create some data first. Now when we look in user objects, we actually have 6 things to look at. We have the index and the table themselves. That's the ones with sub-object name of null. And then we have the partitions for each of those segments as well. So we have P1 and P2 for the index and P1 and P2 for the table. And we can see that 30 seconds past the minute, I created the table, and at 36 seconds past the minute, I created the index and its partitions. Let's take one of the partitions of that index and make it unusable and see what we get. So now the index itself has been changed its DDL time, as has the partition we touched. The other partition remains unchanged at 36 seconds past the minute. The table also gets marked as having changed, but in this case, the equivalent table partition does not. So just the table at the highest level gets marked as having DDL, plus the index, plus the partition that we actually tweaked. If I rebuild that partition, let's see what happens. So now, interestingly here is the index at the high level didn't get changed now. So we got left untouched. The index partition we rebuilt did get updated. It's now 46 seconds past the minute. And the table partitions are also remain untouched. So unlike the non-partitioned example, where whatever it is, the index always tweak the table and the index, here Setting unusable tweaks the index, the partition, and the table. Rebuilding only tweaks the partition concerned of the index. So some interesting things we get here. Let's now go to one layer deeper again. Drop my table. Now I'm going to have partitions and sub-partitions. So I've got two layers of partitioning now. I'll create an index, local index, so it's got all the same partitioning structure as the table, load in some data. Let's look at our DDL, and we can see here that I've got a table and an index because I ran them all straight away. They're all at 29 seconds past the minute. They all have the same DDL time. Let's change one of the sub-partitions of the index to be unusable. And if we have a look, what happened? The index at the highest level got tweaked. It's now 56 seconds past, as was the table, 56 seconds past. But the sub-partition we actually tweaked has had no change to its DDL time. It is not registered at all. It's just the highest level index and table. The sub-partition is you're blissfully unaware that you actually made it unusable. Let's rebuild that partition now. When I rebuild it, the index at the highest level gets marked as you've had a change, but nothing else. The partition you just rebuilt, you haven't done a DDL to it. The table that holds that index, no DDL as well. The only thing that got tagged as as a fresh DDL was the actual index at the highest level. So it's all quite odd, really. Let's go back to the slides. So there are definitely some idiosyncrasies to be aware of. And these are just ones I discovered when tinkering around with partitions and sub-partitions. There are probably other scenarios as well. Things like you might have, for example, a partition table with lob segments, or just a table with lob segments, and you might do something to the lob, but maybe not the table, etc. I haven't explored those, but there are probably other scenarios. The only thing I'd probably suggest here is that, and I'm tempted to log bugs for these because I think people have a right to think that whatever level object they touch, that should probably tweak the last DDL time. So I'll probably log some bugs for that and speak to the developers, but no guarantees. But one thing I would recommend is if you're actively using last DDL time to see if things have changed in your database, then generally, as you can see, you want to be tracking things at the object level, not the sub-object level. So you really can't trust partition level stuff or sub-partition level stuff. Always be looking at the highest level. The index at the highest level is the only thing you could reliably trust as always being tweaked for its DDL time. So just be aware of that. And I probably would question the philosophy of using last DDL time as some sort of particular flag to detect if you need to do changes. If I'm setting something to unusable, then I would imagine that I would be looking for a status of unusable on my indexes to decide what I need to rebuild, not whether the last DDL time has been tweaked. But I think it's important to realize that you can't simply say, if something doesn't have a last DDL time change, then it hasn't been altered. We've just seen there that it might still be the case that changes have been done. So hopefully that helps explain that one. The alert log on cloud, or even probably more generic, the autonomous alert log, i.e. let me start that whole thing again. Let's talk about the autonomous alert log. Namely, when you're in an environment where you generally don't have operating system access, but you're a DBA that historically has been data mining the alert log, how do we sort of resolve that conflict? And so here's the question that came in. We're developers and we've built some new databases on autonomous, but our DBAs tell us they can't support us because they can't see the alert log. Is that really a deal breaker? And in the generic sense, I would argue that not being able to see an alert log isn't an issue because, for two reasons. Number one is, hello, it's an autonomous database. The reason you sign up for an autonomous database is that someone else has to manage that system for you. That's the objective of autonomous. And especially for developers, that's a very appetizing thing to simply say, I can spool up a database with a few clicks and someone else has to manage all the complexity behind it. I just have to build database objects and write code. So I understand developers' appeal for using autonomous. But if you're in an IT organization which has developers and DBAs, then DBAs might have a vested interest in the fact that you're running databases, even if they're on the cloud. And so you can understand their concerns as well. But the first one is generally, if you can forget about the alert log and make it someone else's problem, that's a good place to be. Check the chat. Yeah, Hement said it's often auditors that go hacking around in last DDL time. And so, yeah, that's a worthy comment. The second thing that's worth noting, that even on cloud managed systems such as Autonomous, is the alert log is actually there and you can still access it. And in fact, you can access it in actually more impressive ways than you could if you had operating system access. Let's explore with a demo. So I'm doing this on my local machine, but the same applies on any of our cloud databases. The first thing I'm going to go looking for is there a VDollar view that lets me see the alert log? And the first place I'll look obviously is VDollar diag info, which normally gives me all the default information. And it tells me all the directories, etc. But nothing there stands out as being a pointer to the actual alert log. I've got the trace file, but I haven't got the alert log in any way, shape, or form. If I go look at VDollar fixed view definition, which lists all the VDollar views in the database, for things that have the word diag in them, I've got diag trace file, app trace file contents, etc. But nothing there that suggests I've got the alert log, which is a bit disappointing. If I go look in VDollar fixed view definition, there's nothing that has the word alert in it that's in the diags sort of infrastructure. So at that point, you might be thinking, well, maybe there's no access to the alert log. Interestingly, if I go look at DBA objects for things that start with VDollar diag, I get a lot more stuff. And that's one thing I wanted to point out on this little sort of thing tonight was it's worthy of note that the concept of a VDollar view being a virtual table based on something in memory has become a much more loose definition as the database has evolved. A lot of these VDollar views are actually pointers to things on flat files. They're like external tables. And as a result, VDollar fixed view definition is actually just those things which are genuine virtual tables pointing to memory structures or things like the control file. Now, there's a lot more scope for what constitutes a VDollar view. Out of those 107 rows, if I go looking for ones that have the word alert, I have VDollar diag alert ext for external table. And yes, that is a view of the alert log you can get via SQL. So if I describe it, one of the cool things here is, unlike what we would have to do if you had to dig into the operating system layer, is the alert log you don't have to parse. You have to go work out what rows are the timestamps, what rows are this. The way this works is it's not looking at the VDollar, the alert log text file on your database. It's looking at the alternate directory, which is the alert log XML structures that also get written in your diag area. If you hear that, that's just my dog shaking his head. Bear with me, he needs to go outside. Apologies, just proof that we're doing this live. So unlike the operating system where you have to go digging and parsing text files, the alert log external table is looking at the XML structures, which are obviously well formatted, and therefore it can turn that using XML table commands into columns and rows in the database. So we can query it. This is the alert log on my machine here. And I've simply grabbed, I think if I scroll back a bit, I've got like, yeah, just for the last 24 hours. And you can see effectively, what's been going on this version 19 database running on this Windows machine. And the good thing is because it's all columns and stuff, I can add where clauses and predicates, etc. It's much easier to actually data mine this alert log than it would be if I was a DBA digging around in the operating system. One of the good things, especially because it's a relational structure, is I now have the ability to dig into certain elements. I'm connected to a pluggable database. That pluggable database is container number 3. It's PDB1 on this laptop here. And when I query the alert log, which is a single file that sits across the entire database, I only get entries in here for my container. So I'm not breaching any security rules here. And even if I wanted to, I can't. But the other benefit is I'm not going to see information in here that doesn't pertain to this particular pluggable database. Much easier than at the operating system layer. If I connect to SysDBA, so now I'm connected to the container, the root container. If I do this, you can see I actually get the alert log information for all the pluggables. And in fact, this machine currently only has pluggables PDB1 and PDB2, AppCon1, AppPDB1, etc. is stuff that I've had in the past that I've since dropped. but the alert log still contains the information, and therefore I can still see it from the root. If I do a query for con ID and container name from the root, I can see I have 55,000 entries for PDB1, which is the one I spend most of my life in, and just a few for CDB $root. What's in my alert log on this machine? You can see I've got alert log entries going back all the way to 12th of August 2021, which shows you how diligent I am about cleaning up my alert log on this machine. So if I'm running a cloud database, then that duration is managed not by you, it's managed by the people running that cloud database on Autonomous. So let me just fire up a new share, which shows you my Autonomous system, just so we have an idea of what the duration is like on Autonomous. This will be a bit slow. It's connecting to an Autonomous database in the US. Let me just grab that same query that we had on. Okay, what's the minimum entry in the alert log on ATP? And 7th of September. Now, given that today is the 15th of September, I think we can reasonably safely assume that we have about a 1 week duration on the alert log on your Autonomous database. Oh, sorry, I killed a session I shouldn't have. There we go. Okay, hopefully you can see I've come back to my local system. So typically we expect about a week on the Autonomous database for the alert log duration. And the question is, well, what if I want to see more? What if I have existing scripts that used to look through 6 months of data for, trends, etc.? Well, because it's now a table, it's really easy to manage that. I simply do a create table local alert, a select star from the alert log external, and now I have a local relational copy of my alert log. If I look at that, I've got from 12th of August to 15th of September, 9:30 p.m. Now let's put some entries in my alert log. So I'll create a table space, I'll drop a table space. That's an easy way of getting some stuff in my alert log. And this is all I have to do every day, is add to my local alert table everything from the alert log where the originating timestamp is greater than the most recent thing I currently already had. It simply goes and gets everything since the last time I refreshed it. And now if I run that same query as before, if we go down here, we can see we've got stuff from 9:42 now, which are those commands. I created the table space, I dropped the table space, etc. So even though you've only got a week's worth of alert log on the Autonomous database, the fact that it's easily accessible via a query and the fact that you can simply augment your own local copy for as long as you want, there's really no restrictions. You could have the alert log forever simply by appending to it as you go. So nice and easy to do. So the alert log is there. It's easy to create your own copy because we control the duration, which is 7 days in Autonomous, or at least on my Autonomous database. 9:44. Defaults. This is one I actually put in today because just yesterday, I tweeted out a video that I'd done about %free, and someone tweeted back this to me. Is it good that the default for %free, which started off as a %free of 10 as the default way back in Oracle, whenever, probably 6, is still a default of 10 on all databases, including ADW? So ultimately, I want to talk about this in two particular ways. Is %free 10 a good idea on a modern database? And in a general sense, if it's not a good idea, why doesn't Oracle change defaults as we move through releases to more reflect modern practices? Now, I want to take a little quick trip down memory lane here. Back in the day when I started first working with databases, this is what hard drives looked like for our servers. And they were all based on, effectively, they came in little boxes like this. This is a Hewlett Packard, but I was working with Sun. And they were, you probably remember those big, enormous, fat SCSI cables. We had SCSI, fast, wide SCSI, etc. Each cable got bigger and fatter and theoretically faster. But things like this were expensive, big and bulky. They're like sort of the size of like a shoebox. And this one was 4 gig. 4 gig was, a pretty impressive drive. And then later when we went to 9 gig, which was, insane. And so, it was just ridiculous. If you go back even before then, because when I first started working in IT, I hate sharing this information, I was a COBOL programmer on a mainframe. Oracle didn't exist. And on mainframes, disks like this were an insane luxury. There was no such thing. On the mainframe I worked on, we didn't even own it. We rented our mainframe. And this was back in 1988. I think it was the last time I used our mainframe before I started getting involved with Oracle. And our mainframe, we used to pay $120 per gigabyte per month for storage. Plus, those disks came in enclosures, and we paid $1,100 per enclosure per month, and each enclosure held 3 gigabytes. So you had 3 disks, each at $120 a month. That's $360 plus $1,100. So you're basically paying about $1,600 every month to have 3 gigabytes of storage. And so if you had 10 gigabytes of storage, you'd pay triple that, etc. It was insane. And because of that, because disk drives weren't this flippant thing we think about nowadays, well, applications you built, you would try to do as few inserts as possible. Generally, you would update data rather than insert new versions of data. And rest assured, you spend a lot of time making sure you cleaned up your mess. We always had, very strict guidelines as to how long we would hold data. We make sure we get rid of it, because every row you deleted would ultimately end up saving you dollars, because disks and disk infrastructure was incredibly expensive. You fast forward to today, and I can buy an 18 terabyte hard drive for $600. So rather than 122 gigabytes a month, you do the maths and it works out as 3 cents per gigabyte, and not per month, like it's forever. And they don't come in enclosures. So your total price, instead of being $1,500 for 3 gigabytes per month, it's now 3 cents per gigabyte forever. And so disk space is a non-issue nowadays, generally on almost all infrastructure. As a result, the mindset, I think, of all projects has changed. And I always view this as when you come out to archiving and removing old data, most projects I work on nowadays work like this. Your project goes live at a certain time, and whenever it goes live, the archival of data phase is sometime in the future. That's the next phase of the project that we'll hope to get to at some stage in the future, but it's low priority. When you release version 2 of your application a year down the track, obviously the time in which you would now tackle the archival phase has approached, but of course, what do? You just push that out. And so, McDonald's theory of archival is if your project is at version N, then the archival project is N+1 for all versions of N. It's as simple as that. We so rarely archive information now because it's complex, it's hard, and often people simply say, why don't we just get more disk? Archival is now an afterthought. Check the chat line. A couple of quick questions. So the only difference is you pay for storage in your local alert, but not for the original one. True. But I think you'd have to work pretty hard to get an alert log of any large kind of size. Sven, I think that's being a little bit facetious there, because the reality is I don't think you'd ever get to alert log more than a few gigabytes at most. Angel said, out of context question, how you connect Autonomous? Yes, that is a good point. To connect to Autonomous, we always do it securely. We always encrypt the connection. So yes, you have to download a wallet. I should note though, that as of the 21C drivers, both OCI and Java, you can have a thing called mutual TLS or MTLS. If you go to your cloud console, you can turn on MTLS, which means you can connect securely without a wallet. So if you search for MTLS or connection without a wallet Autonomous, you'll see that in the latest version of all our drivers, you can now connect without having to have the overhead or complexity of a wallet. Not that I think they're that complex anyway. I wonder if that link someone's put in the chat is exactly what I was talking about, but I won't click on it now because we're running out of time. Thus, the traditional way of let's do not many inserts, lots of updates, and lots of deletes to make sure our disk space doesn't get sort of consumed. Well, no one deletes anymore. We just don't bother. We don't do many updates, and we keep adding more and more data to our systems. Systems have become very insert driven, because the mindset of modern applications is there's probably some value in that data no matter how old or out of date it is, so we may as well keep it because the cost of keeping it is very low, so let's keep it just in case. What that means is, and one of the things that I recommend to people if they're starting on applications where they'll probably just be loading data all the time, is create your tables with %free equals 2. That's generally my default now when I'm using for a table, because I don't like going %free 0, because %free 2 means I'm using 98% of the available space in my block, but I'm leaving a little bit of room for maybe the occasional update in case there's a data patching and stuff like that. I'm not going to end up with a migrated row. And also, I'm making sure that just in case I have a few concurrent transactions on my table, then there'll be enough room for the intra-transaction list, the ITLs, to grow. You get 2 by default in a block, but I want to make sure that maybe I need to grow to 3 or 4. So just even that little bit of overhead, that 2% of free space, I think is probably a really suitable default for the vast majority of applications that we build nowadays. So to answer the first part of the question, is %free 10 a good default? I think for most modern applications, I would be leaning more toward 2, except for those particular cases where we have some sort of divergence from that recommendation. So one of the examples is, if I've got really static old data I'm never going to touch again, I'd probably either load it with %free 0 or compress it with %free 0, because that's automatic when you compress the data, and leave it alone. So there are obviously exceptions to the rule, but for me, %free 2 seems a reasonably good starting point for most applications. But as I stress, just because it's a default doesn't mean it's a cast iron rule. If I got rows that I know are going to grow, I'm going to bump up my %free. If I've got lots of transactions, I'm going to bump up my %free. But hopefully that answers the first part of that question. What do I think a sensible default is for %free in modern applications? I think 2. The second part is, well, if that seems a relatively plausible explanation, well, why doesn't Oracle just do that? Why don't we make the default of 2 for all new databases coming out? And that brings me on to a topic called yak shaving. Now, if you're unfamiliar with the term yak shaving, let me explain best with a demo. Let's say I want to wash my car. I want to wash my car, but I can't. You know why? Because the hose is broken. And the problem is, to fix the hose, I need to go to the hardware store. And to go to the hardware store is a pain because it's on the other side of the freeway, which has tolls, and now I've got to pay tolls. So rather than do that, I'd rather take public transport, but I don't use public transport, therefore I don't have all the appropriate stuff. But my neighbor, he catches public transport all the time, so I could probably go and borrow his public transport card, to make it easier. I don't really want to go see my neighbor though, because my son borrowed one of his cushions the other day, and unfortunately the dog tore the cushion apart, and so it's missing some hair inside it, and I need to repack that cushion. That cushion needs to be repacked with yak hair. So the next thing you know, I'm down at Perth Zoo, getting ready to shave a yak. That's the term yak shaving. That's the story that sort of produced this. And the concept is, to achieve something, often you end up having to do something totally unrelated in order to work your way back to the original goal. And when it comes to setting defaults in the database, it's a bit like yak shaving, in the sense that so many things have to be done or changed to do what seems the most trivial change. Let me give you an example of why I believe it's so much harder to change a default than you might think. Most people, when they create a table, don't bother with %free. They just do create table. Maybe they'll put a table space in. Therefore, almost all the tables out there in the world at the moment probably have %free of 10, which means they look a bit like this. Now, if we change the default to %free, say 2, then we can now get those extra 3 rows inside our blocks. Therefore, there's a good chance that people will be, in the main, happier. If we change from 10 to 2 as a global default for all versions of the Oracle database coming out in the future, there's a good chance people will be happier. There's an excellent chance they won't be happier because they won't even notice. The vast majority of people who don't set %free are blissfully unaware about %free 10 and why it's wasting 10% of a block space. They're just unaware, they don't care. So yes, we actually improve the data density. The question of whether people will be dramatically happier, I think, is dubious, because those people that already know about this are setting it anyway. Those people that don't will be none the wiser. But let's say we have set percent free to 2 as a global default for all new systems. Well, up until now, people have been updating rows, and even if they were unaware of percent free 10, have been lucky. As they make rows larger, those rows haven't been migrated because there's always been that 10% free space. Now, the systems that actually do still update lots of rows and make them larger, well, now you've got unhappy users because all of a sudden they've got a migrated row issue. But I happily concede the same argument applies here. If they were blissfully unaware about percent free 10 and percent free 2, they're more likely to be blissfully unaware of row migration and row chaining. Definitely. They're probably unlikely to even notice the difference. However, one thing they will notice is, let's say in a system where we have percent free 10, people have a lot of concurrent transactions. Well, if I've got a lot of concurrent transactions on a block, they'll all work fine because percent free 10 lets the ITLs, the interested transaction list, grow to match that level of concurrency. All those transactions are going to work just fine. If I've changed the default to be percent free 2, all it takes is one customer who has 4 or 5 or 6 concurrent transactions on a block, and all of a sudden they've got locking problems. Now, whether they're blissfully ignorant of percent free 10 or not, that they will notice, and they will notice huge, because all of a sudden something that worked before is now getting row lock contention, and they're thinking, I'm not even changing the same rows. It's a mystery to them, but they're having locking problems. And so these are the kind of people that will absolutely lose their mind because, they'll be on Twitter. Rest assured, they'll be on Twitter. They'll be screaming at Oracle and Mike Dietrich, who's the upgrade PM. I upgraded my database and it broke my application. Upgrade sucks, yada, yada, yada. So enormous risk in changing what is a simple default to what will probably suit most people, because all you need is a couple of people where they don't understand the implications of this, and they will absolutely lose their mind in a public forum because for them it's simply, I upgraded and the world went to pot. So maybe we do this instead. Maybe we had a parameter now saying, what do you want the percent free default to be? So maybe we introduce this in 26C or 28C, etc. So you have a new parameter. What do you want the percent free default to be? And you choose to 2, but other people can set it back to 10 if they want to. The first thing that happens there is people go, too many parameters. Oracle, too many parameters, it's too complex, yada, yada, yada. You will have noticed that Oracle has been going the opposite direction for the last 5 years. We're trying to get less and less parameters that you need to tune because the database should be a nice self-managing, easy thing to install and manage. This goes in the opposite direction. Maybe we make a hidden parameter then. Maybe that's the solution. Therefore, it still looks like we have less parameters. We have a new hidden parameter, which will do it. Well, what's going to happen then is the next time you run an AWR report or an ASH report and it says, okay, parameters modified with container, you'll see that there's a percent free default there that's now hidden. It might be 2, it might be 10, but whatever it is, it's going to show up. Next time you try log an SR and you're logging a problem which has absolutely nothing to do with percent free, there's a good chance support are going to say, well, we noticed that hidden parameter you've tweaked. Can you please reproduce your problem without that parameter set? And guess what? Next thing you're on Twitter again. My Oracle support, everything's so hard. It was so complex talking to Oracle support, etc. So I'm not begrudging people's desire to have defaults changed. But the reality is adding the tiniest default we want to change has huge implications. And the risk portfolio for customers is massive because all you have to do is impact a couple of customers in a negative way, and the backlash is huge. And that's not something where any of us want to be. So we do our best to change defaults as safely as possible. And I make no claim that we get it right all the time, but we do. I'll give you some examples. Undo management. We could safely say that back in the Oracle 9 timeframe, the number of people who were actively and very aggressively and carefully monitoring their rollback segments and choosing, remember the rollback segments parameter where you listed all the segments and which ones were online and offline, and then you had transactions per rollback segment, etc. No one was doing that. Everyone pretty much went with the defaults. So it was very safe for us to say, look, we're going to take undo management and make it automatic because most people are not doing any kind of manual undo anyway. And this is actually going to be a better solution. So this was a change of defaults, and it, generally everyone prospered. Here's another one from more recently in 12.2 when we introduced private statistics for global temporary tables. It was nigh on impossible to have good stats for a global temporary table because they were across all sessions. And the whole premise behind a global temporary table is private data per session. Therefore, we could not think of a single scenario where it would make sense to have a single set of stats for all instances of a global temporary table. And so we made private stats the default when it came in 12.2. Once again, I think an intelligent use because the existing use was fundamentally flawed. Now, I'm not claiming we get it right all the time. Also, remember in 12.1, we went with this new default system. The two kinds of adaptive optimizer stats both defaulted to true. This was probably a mistake in our part. We were perhaps too aggressive in going for that default. And one thing I'm particularly proud of is Oracle said, look, we made a mistake, we'll walk that back. And in 12.2, that second parameter got set to false as a much more sensible default. So we try always put sensible defaults in place where we think the backlash or the regression risks are very, very low, or the benefit of having this new default massively outweighs the previous feature. But I suppose what I'm trying to say is the reality is simply tweaking a default, given that we've got 30 years of Oracle customers out there, is nowhere near as trivial as you might think. So hopefully you'll cut us some slack in that line. So once again, you can tell when I run over time, I've been pontificating and ranting too long, but hopefully you support my passion on some of these things. Thank you very much again, always for your time. We don't need to see that anymore. Hope you enjoyed this session's office hours. We got through a few bits and pieces, and we'll get through the rest next month. I'm off to Germany in a couple of days' time. So if you're at the DOAG conference, please come say hello. I'll happily buy you a coffee or a beer on my trusty corporate card, and we'd love to catch up and talk tech and actually do something face-to-face. Otherwise, I hope to see you at Cloud World in October. For that reason, I might not have an office hours next month. We'll see how the timing goes. But yeah, either DOAG or Cloud World, I'd love to see you face-to-face. If you can't see me face-to-face, please do me a favor, get out to your local user groups, whatever they're having, support them, give a speech, just to be an attendee, anything you can do to give them a kickstart so we can get some community love going again. Thank you very much for your time, everyone. If I didn't get to answer your questions, hit me up on Twitter, and otherwise I'll see you next month or somewhere else for office hours. Bye for now, everybody.